Hi everyone, this section is on powers of 10 and scientific notation. So with the powers of 10 in scientific notation, each time you divide by 10, the exponent is going to decrease by 1, and the decimal point is going to move one place to the right. Each time you multiply by 10, the exponent increases by 1, and the decimal point moves one place to the right. So in this chart right here, it's showing you when you divide by 10, how the exponent is decreasing. When you're multiplying by 10, the number of zeros is decreasing as well here. So we have 10 to the third, 10 squared. Here we have 1,100. So notice the pattern taking place with the powers. Notice the pattern taking place with the values. So 10 to the third is 1,000. 10 squared is 100. So notice when we decrease in the exponent, we decrease in the value. 10 to the first is 10. 10 to the 0 is 1. So please write down both of these explanations along with the chart. The next thing you'll see here is powers of 10 in scientific notation. So I do want you writing down these definitions and the examples as well. So power integer exponents. If n is a positive integer, find the value of 10 to the nth power by starting with 1 and moving the decimal point n places to the right. So we have an example here where 10 to the fourth power, my exponent is positive. So like the definition just stated, we're going to start with the value 1. We're going to put the decimal point right after the value 1 and move that decimal 4 places to the right because it's a positive integer to get a new value of 10,000. So positive exponent, we put the decimal after 1 and move the decimal point n places to the right depending on the exponent. For negative integer exponents, if n is a positive integer, find the value of 10 to the negative n by starting with 1 and moving the decimal point n places to the left. So here we have an example, 10 to the negative sixth power. Like in the previous lesson, when you have a negative exponent, you have your numerator as 1, then the denominator is that base with the exponent. Now it's 10 to the sixth. So what we're going to do is we start with the value 1, we put the decimal after 1, we're going to move the decimal place to the left now because it's negative 6 places to get the following value. So when it's a negative exponent, we're going to move the decimal point to the left. So notice the difference between positive integer exponents and negative integer exponents. Here we have the definition of scientific notation. It's a method of writing numbers that are very large or very small. A number in scientific notation has two parts that are going to be multiplied. So we have the red part here, which is the first part of the number that is greater than or equal to 1 and less than 10. The blue part here is the second part of this when we're working with the power of 10. So our first large number is 3.5 times 10 to the 11th. Our second large value is 9.98 times 10 to the negative second power. So what we're going to do in the next few examples is I'm going to show you ways to write powers with 10 and also writing scientific notation. Here we have, don't pay attention to these examples here, I was just writing some things down. So we have here, find the value of each power of 10. So for A, we have 10 to the negative second power. Notice we have a negative exponent here. So if we have our negative exponent, we have our value 1. We put the decimal place after the 1. And the exponent is negative 2. So we're going to take that decimal, move it 2 places to the left since it is negative. Move the decimal, put a 0 replacing that empty space. So we would have 0.01 for our answer. And in the notes you will see that. So it says start with 1, move the decimal point 2 places to the left. You just saw that I did that. And you get your final answer of 0.01, or 1/100th. Our next example B, we have 10 to the 5th. So our exponent here is positive. So we have our value 1. We put our decimal point after 1. Now it's a positive exponent, so now we're moving that decimal place to the right. We'll move it to the right 5 places. 1, 2, 3, 4, 5. Fill in those empty gaps with zeros. Then put in your commas. So here we have 100,000. I'm going to erase that, and you'll see in the notes that what I just showed you is what exactly you need to do. So start with 1, move the decimal point 5 places to the right, and you get your final answer of 100,000. The next one we have here is 10 to the 10th power. So we have our value 1. We put the decimal point after 1. Now it's again positive. I can keep that positive. There it is, positive. So we're going to move the decimal 10 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, fill in the empty spaces with zeros. Filling in your commas. So we have here 1 billion for our value. Sorry, there's a lot going on here. Let me erase this. So it says start with 1, move the decimal point 10 places to the right, and you get your final answer of 10 billion. Sorry, I think I forgot a 0, so it's going to be 10 billion right there. The next part of this, it says write each number as a power of 10. So now we're actually going to be doing the opposite of what we just did. So we have our value now, but now we have to write it with the power of 10. So if we look at the first value, we have here 100 million. So what we're going to do is the decimal point is 8 places to the right of 1, so the exponent's going to be 8. And if we look at this, here we have 1. If we put a pretend decimal point after 1 and go to the end of where the zeros stop, we're moving it 1, 2, 3, 4, 5, 6, 7, 8. So the way I'd write my final answer is 10 to the 8th power. Notice for B, we have now a decimal. So what we did is we moved a decimal value answer. So we moved the decimal to the left. So we have 0.0001. What we're going to do is the decimal point is 4 spaces to the left, so the exponent is -4. So if I put my decimal after that 1, I move it to where it's placed. 1, 2, 3, 4. So we definitely move that decimal 4 places to the left. So my final answer here is 10 to the -4th power. Last example on the slide, we have 0.1. Again, it's a decimal. So we're going to move the decimal point, since the decimal point is 1 place to the left of 1, the exponent is -1. If I show you here, if we put the decimal after 1, move it 1 place to the left, my final answer is going to be 10 to the -1 power. Here we have example 3. It says find the value of each expression. So here we have 853.4 times 10 to the 5th. So I will write 853.4. Now it's saying times 10 to the 5th. So what it's saying now, it's a positive exponent. So that means we're going to take that decimal and move it to the right. But how many places to the right? 5 places. So this is 1, 2, 3, 4, 5. We will fill in the rest of the empty spaces with zeros to get my answer. Don't forget to put in your commas. So we have this large number. Let me erase here so I can show you it clear by the typed version. Here is my answer. We have 85,340,000, and that is my value of this scientific notation example right here. Let's look at B. We have 0.01. 0.163 times 10 to the negative second. So I'll write 0.163. Here we have a negative exponent, negative 2. So I'm going to take that decimal and move it 2 places to the left since it is a negative. Fill in that empty gap with the 0. So we have 0.00163. Let me erase this. So what I have here, I showed you the examples, and here again is 0.00163, and that is your final answer. This last example, they are going to give you various scientific notation values, and they want you to put them in order from least to greatest. So here are the values. We have 5.2 times 10 to the negative third, 3 times 10 to the 14th, 4 times 10 to the negative third, 2 times 10 to the negative 12th, 4.5 times 10 to the 30th, and 4.5 times 10 to the 14th. So our first step with these values is we have to list the numbers in order by the powers of 10. Okay, so looking at the powers of 10, we have 10 to the 12th, 10 to the third, 10 to the 10 to the negative third, 10 to the negative third, 10 to the 14th, 10 to the 14th, 10 to the 30th. So we put them in order from least to greatest based on the powers of 10 and the exponential values. And then our second step will just then put the order of the numbers that have the same power of 10. So we have 2 times 10 to the negative 12th. What we just really did is we rewrote this out. And notice how the ones in red, they both have 10 to the negative third power. So from least to greatest, 4 is less than 5.2. So it's just showing you how you would put numbers, values with the same exponents in when it asks for least to greatest. Here we both have 10 to the 14th. Since 3 is less than 4.5, this is least to greatest. And then we have our greatest value is 4.5 times 10 to the 30th. And so this here is your final answer, the order of these values from least to greatest.